Welcome, everyone. Great to see a full room. Welcome to this breakout on the Using Docker for Development track. We have two excellent speakers, Laura Frank and Olly Pomeroy, who will be talking about building your development pipeline. It's going to be a session full of how-tos and hands-on stuff. I think it's going to be very interesting, perhaps a demo or two. Let me introduce the speakers first. Laura Frank is a captain, or as I like to think of her as a captain plus plus. Has been working with Docker since 2013. It was great to meet her yesterday and chat with her. Laura lives in Austria, in the beautiful city of Vienna. Part American, but I think we'll say she's multinational. Laura works for CloudBees. We've all heard of them and the work they've done with Jenkins these days. Laura speaks German too, is that correct? I can verify that. I don't know the language. Olly is a solution engineer from Docker, lives in London. Every time I meet someone from London, I hope there's a little bit of cricket interest there, but didn't work out this time either. Not very popular anymore. All right, great. Let's leave it to the speakers. I think they will take this away and take care of the rest. Thank you.
Cool. Thank you.
Good. Hello, everyone. Glad that you can join us. I know we're separating you from lunch, but I promise it will be worth your while. Olly and I will be talking about building your development pipeline for the next 40 minutes or so. As we were introduced in a lovely way, this is Olly. He is a tall British man who likes containers. I'm Laura. I work at CloudBees. I also really like containers, so you're in good hands. To start off with, I want to talk about what a pipeline is and get us to a common definition so that everyone understands what exactly we're talking about over the next 35 minutes or so. When we talk about a development pipeline or a deployment pipeline, what we're talking about is a set of processes to make your software development process more efficient, higher quality, more performant, and more secure. So because this is DockerCon and we're talking about using, we're talking about using containers specifically. I feel like I had this problem and I was like moving the wrong way on the stage. We're talking about containers, so we're going to talk about building a container image. So we'll talk about building it with a build agent. We'll talk about automating the testing for the code that's going inside of the image. We'll talk about security scanning and making sure there's no vulnerabilities shipping to production. And then finally, we'll talk about promoting the image and actually getting it into your production environment in front of your customers. So we're going to mostly cover these 4 parts, which is build, test, secure, and deploy. And Olly has prepared some awesome live demos for a lot of the segments during this talk. So to start out, why use containers for your pipeline, aside from the fact that we're sitting here at DockerCon? So it's about what's inside of the container. So containers make it really easy to create consistent environments. Everything is sort of compacted inside of that little environment, and you can move it from stage to stage or from environment to environment really easily. You know exactly what's running because it's all declared in a Docker file and with supporting files like a DockerCompose file. You can also share these common artifacts across teams or across environments, which makes it really efficient. Aside from what's inside the container, though, just using containers will unlock different workflows for your teams and your business. Because the containers are so lightweight, you can use them just as compute power in more interesting ways. So for example, it might not have been very possible to just fan out a bunch of servers in the past, but with containers, starting up a container just takes maybe a second or under a second. So you're able to do more work with fewer resources by using containers. You also have the extra benefit of using common tooling across your different environments and even across different teams. So if you're using a Docker file in test and you use it in prod or you're using it also in dev, your engineers don't have to learn brand new stuff for each stage. That gives your developers more autonomy and helps your teams work a little bit more efficiently together. Olly and I both want to warn you, though, that there are no shortcuts in this process. So Docker is going to unlock a lot of value for you, and it's going to help you. But a lot of the stuff is still our responsibility as developers. So things like making sure your dependencies are pinned, paying attention to sizes of images, making sure you have enough space on disk, security, vulnerability scanning, those are all things that need humans to make sure that they're taken care of, but Docker can certainly help.
Cool. OK, so moving to the first part of the pipeline, sort of building container images in a pipeline. The first part of that we'll look into is build agents. And here we're talking about what the kind of state looks like for current build agents today. First, what you find when you look at existing build agents, they're normally pretty underutilized. They're normally sized for the biggest pipeline job, sized for the biggest task you're running. So a lot of the time, they're either sat there idle, or they're doing pretty low jobs which aren't using up all of their resources. One of the sort of similar things we see with virtualization, kind of underutilized VMs. And then the second big problem you have with traditional build agents, we often find developers aren't very good at standardizing on their tools, or standardizing on the versions of the tools that they use. Therefore, you end up with a huge kind of dependency mess on all of your build agents, making sure all of your build agents are suitable for all of your pipelines, trying to handle that dependency mess when you upgrade to new versions, and so on and so forth. Containers can come in, and containers can help on both of these aspects when you start to use containerized build agents. The first benefit you get, they can be on demand. When a developer starts a new pipeline job or a team starts a new pipeline job, your pipeline can talk out to your Docker environments, to your Docker clusters, spin up containers on demand to do your build jobs. So you no longer have underutilized build agents that are lying around. You have build agents as and when you need them. And as Laura talked about before, you can start to fan out and run multiple jobs in parallel on probably the same underlying hardware. Then on the same time, you also don't have to package every single tool and dependency inside of those build agents. Containerized build agents, you could have one particular Docker image for each job. You can even start to do the thing now where the responsibility of maintaining those build agents starts to move away from maybe the operations teams, and developers can build the build agents they need with the tools that they require and kind of start to share the responsibility, not putting everything on the operations and the infrastructure team. The first question that comes back, though, one of the common problems we have out there is, well, when you start to use containerized build agents, first question that comes back, are they secure? Is this a secure way to build artifacts? So let's look at the two ways right now that you can build container images inside of a containerized build agent. The first thing we have here is Docker and Docker. So if you picture you having a virtual machine, you have Docker installed on your virtual machine, and you want to start a build agent, first thing we can do, or the first option we have, is we can run a second version of Docker inside of a container. So now there's the Docker on the host and a second daemon inside of the container. Attached to that containerized build agent, and we now have a whole new place to build containers. We now can on demand bring up a container, talk to this containerized Docker, and start to build ourselves container images. As you can see here, though, the way this is done is using the privilege flag. The Docker daemon itself requires a lot of low-level system calls to function, so we require this privilege flag to give your container enough capabilities to run the daemon. It's kind of a bit of an inception, right? You're running Docker in Docker. Option number 2, mounted socket. We have a virtual machine. You have Docker installed on your virtual machine. The second option you have here in terms for your containerized build agents is you could mount the Docker socket from the host into the container. You can then run the Docker client inside of your container build agent talking to that one instance of Docker. So you can see here I'm just using the Docker run command in the example, but I'm actually mounting in the Docker socket, which is running on a Linux virtual machine inside of my build agent. Now my build agent has access to run Docker images, to run Docker PS, to do all of its builds natively inside. But don't worry, though, this is not just for Linux. We can absolutely do the same approach on Windows. We can't run the Docker and Docker approach on Windows because we don't support privileged containers on Windows. But if you wanted to start to do containerized build agents for your Windows environments, this technique works exactly the same. On the Windows side, you actually have a pipe rather than a socket, but you can absolutely mount that pipe inside of your container image, inside of your build agents, and then you can start to run build jobs in containers on Docker and Docker for Windows. So here you can absolutely see the images and a running container on the local machine. But then it kind of goes back to the original question. is this secure? Like, what have we actually done to achieve building in a container? Well, the privileged approach gave us a pretty privileged container. Running that privileged flag means your container can pretty much do everything the host can do. It kind of breaks out a lot of the isolation benefits you get from containers. Or mounting a socket might actually bypass a lot of the security controls that you have. If you have an authorization plugin on the socket, or if you're using, I don't know, like Docker Enterprise with an RBAC engine on there, mounting the socket inside of a build agent, your Docker API calls are going straight to the socket rather than through your RBAC engine. So you might say, well, am I giving developers more access, more privileges if I mount these sockets? So is this secure? What can I do? What are actually customers doing to do this? Because these two approaches are very, very popular in how everybody today builds container images. Well, on the Docker and Docker side, we're doing a few different things. First off, the ecosystem right now are working on ways to be able to run Docker without privileges, kind of like a rootless Docker, so to speak. Or Docker themselves, we're actually building a standalone building daemon, something called BuildKit, and we'll talk a bit more about that later on, but that's kind of the first iteration of a builder without using the Docker engine. So maybe we can run that in a container without all of its privileges. Or at the same time today, what I often see out there in the market is I see people use dedicated build hosts or dedicated build clusters to run a mounted socket. The mounted socket is one of the cleaner ways to do this, but let's say you wouldn't be building container images on your production clusters, so end up having kind of dedicated build hosts or dedicated build clusters to kind of get around that security concern. OK, so going back, right, we now have our containerized build agents. We're reasonably happy on how we're going to do that. But how do we optimize? I talked about before that we're now starting to build more things than we used to. Containerization means that we can start to run more jobs on the same infrastructure. How do I optimize my build jobs? How do I optimize my build containers? First thing I'll say, multi-stage builds. Multi-stage builds came in around about 18 months ago now in Docker C 1705, but it basically meant that in one Docker file, you could define two containers. The first container in this example builds a Go binary, so it has like Golang installed and has the ability to compile a binary. And then the second context here is a small lightweight Alpine image, which just runs this binary. What this actually means is that the end state container image is going to be a lot smaller. It's also going to be a lot more secure, because all of the binaries and so on that we need to compile my application or build my application won't end up being in its runtime state. So now I have smaller images to go through my pipeline and more secure images because we don't have all the unnecessary artifacts and binaries. And one of the benefits of actually speaking first here today is we can plug other people's talks. So if you want to know more about this, go and check out Tibor and Sebastian's Dockerfile best practices later on today. OK. What other benefits can I use to optimize building containers, building containers in build agents? BuildKit. I talked about it before. It was originally a standalone build daemon that we've been working on, but we're also now starting to integrate it inside of the Docker engine, replacing the standalone Docker build that we have today. BuildKit brings us a whole host of advantages around sort of security, options around building different Docker files or even building different artifacts. But one of the main benefits it brings for pipeline development is a huge speed performance boost. If you look just comparing BuildKit versus the standard Docker build functionality in 1803, if this was a one-off first-time build, BuildKit is 2 times quicker than just standalone Docker build. But in pipelines, you're not often starting from scratch. You're often kind of running the same pipeline multiple times. There's obviously quite a lot of caching involved. If BuildKit's running on a cached job, something that's already built, we're actually seeing sort of 7 times improvement over the standalone Docker build. So now when you start to containerize your build agents and run build jobs in those containerized build agents, I'd recommend turning on BuildKit. It's there today, shipping in CE 1806 and EE 1809, and so you can start to take advantage of a lot quicker builds. Once again, a second plug. Tibor and Ian are talking about this tomorrow morning. They're doing a deep dive on BuildKit, so I'd recommend checking that out. Cool. Time for a quick demo.
You have no grapes, so I really hope this goes well.
Yeah, me too. Yeah.
No pressure.
OK, so the first demonstration I'm going to look at is kind of building container images in containerized build agents. This demonstration here takes advantage of Docker Enterprise. So you see that I have a Docker Enterprise cluster running here. I'm using Jenkins as my pipeline tool. The registry is Docker Trusted Registry. And I have my application stored nicely in GitHub. Now, as a developer, I don't need to know what those back-end tools were. I didn't really need to care what I don't know, my pipeline or my registry may be. So as a developer, I'll open up my terminal, jump in here, and I'm going to start to make changes to my application. One thing I kind of forgot to call out, this Jenkins job right now, yes, it's a containerized master, but I'm actually running no slaves. Right now, I haven't got any underutilized VMs that are waiting for jobs. So I'm going to jump in. I'm just going to make a quick change to my Docker file. I don't know, my full email address. Why not? That seems like a good idea.
That way we know who to complain to.
Yeah, please don't send me emails. Commit that up into GitHub. Back and type. Push that up into GitHub. We now, as a developer, made a change to my application, pushed it into source control, which should always be the start now of my development pipeline. A quick check into GitHub. Hopefully, we would have had a quick change. And one thing I didn't call out, actually, this is a Windows application. This is a .NET application that I'm actually going to run. So when I do my pipeline jobs, I'm going to want to do this on a Windows container, on a Windows build agent. So new commits come in. Jenkins should have received a notification. Absolutely, it has. And you can start to see a new build job has hit the queue. And we can also see down here, there's a new build agent. It looks like it's offline right now, but it's probably starting up. That Jenkins has received that notification from GitHub. It's received that there's a new commit coming in. It needs somewhere to go and do a Docker build. So it's gone out there to Docker Enterprise in this case and said, hey, I need an environment to do a Docker build in. Can you dynamically provision me a Windows build agent? Quick check into Docker Enterprise. Hopefully, not yet. Give it a quick refresh. Hopefully, we should see the new container turn up here. Maybe.
Guess while we wait for this to load, I noticed you committed right to master, Olly.
I'm sorry.
Yeah, it's for educational purposes only. I think normally we would advocate you to open a PR. OK, looks like I can't get to the dashboard. I'm going to blame conference Wi-Fi. Oh, no. Yeah.
Time to come back.
Cool, yeah, should have ate those grapes.
I should have ate those grapes.
Yeah, I shouldn't have mentioned it. I think it's
But yeah, so right now the container will be provisioned. It would have gone to Docker Enterprise and said, hey, I need a new build agent. Schedule me somewhere for this to run. This is a hybrid environment. So we would have gone to the Windows nodes inside of my environment, scheduled a container. If you look at the container, this one's been named randomly by Docker, but if you look at it a bit lower down, I have mounted in the Docker pipe. My build agent was spun up. It now has access to the underlying Docker engine. It now has the ability to run Docker commands in its container. A quick check of the logs should hopefully show us that Jenkins has started up, and it has inside. So I'm running the Jenkins agent here inside of the container, and it's communicated back with my master. Quick check of the actual build logs itself. Oh, great. Timeout. We should actually start to see some logs as this starts to build. Now, this is going to take a couple of minutes to build, and unfortunately, Windows containers are a bit larger than Linux containers, just because of the amount of dependencies and DLLs that have to be included inside of those Windows-based images. So it's going to take a couple of minutes to build, but we'll check back on its progress in a little bit.
All right. Oops. So while we wait for that image to build, we'll talk a little bit about testing and the different ways that you can test your application using containers, using the images that we just built in your pipeline. So the great thing about building an image and using that as part of your pipeline is that you can reuse that image in multiple stages. So we just built it, and now we're going to run some tests against it. So you can treat this Docker file as a shared artifact and feel very confident that if you build this image locally or you build it in your pipeline, if you run tests against that image, you're going to have the same results because everything is the same housed inside of that Docker file for you. This allows you to be efficient, but then also maintain flexibility in different environments. So if you're an engineer who spends most of their time coding, you're probably going to run tests locally before committing it up to Git and before running this pipeline. Docker is great for this use case because of that Docker file, lets you have confidence that what you're testing locally is the same as it's going to run in your pipeline, and you're not wasting time waiting for that feedback loop to finish. A lot of you might be using DockerCompose to describe the environment for your development environment. And what's cool is that you can use a lot of that declaration in your DockerCompose file to also run integration tests or other unit tests in your dev environment using the same images and Docker files. So I want to just talk about one pattern of how you might do this in practice. This is just sort of a simple pattern. It's not going to fit everyone's use case, but hopefully that, that pattern can apply to whatever you're trying to do. On the left-hand side here, we have a DockerCompose file. This would be my dev environment, and I've used this sample app, which is the voting app, which you may have seen at DockerCon's past. It lets you choose between cats and dogs. Has a bunch of services that are all written in different languages. Sort of a complex architecture. It's a good example for this. So because it's so complex, I want to make sure that my end user experience is exactly what I want it to be. Over on the right-hand side, I have an example of a DockerCompose file used just for testing. And I can spin up those tests with DockerCompose up and make sure that before I kick off my pipeline, I'm going to do some testing to make sure that that pipeline isn't wasted and doesn't have a failure in it. What's really cool about Docker is that I can basically use that same image and spin up those same services in both my local development environment and my local testing environment. So one way to do this is to run sort of an integration test Sidecar service alongside of your application. And I'm doing that over here on the right-hand side by using this test service. This test service is then going to spin up a fresh copy of my application and all of its dependencies, and then execute whatever tests I have declared inside of either my Docker file or in this DockerCompose file. Run the tests, I get the feedback, and then tear down those containers, a really, really quick feedback loop to help me feel more confident before I push everything up and start up my pipeline. In addition to being able to use these with DockerCompose and reuse your Docker files, you can also use a lot of tools in the container ecosystem with your Docker file. So for example, if you're looking for a hosted SaaS service for your CI/CD pipeline, you might want to use Circle, CodeShip, Travis. You can use your Docker files for all of these tools. There's no need to rewrite stuff. You can also do this on-prem with, for example, Jenkins from CloudBees or TeamCity or GitLab or whatever. You can also use it with open source. So it's not just Docker ecosystem tools from Docker, but it's tools from the entire container community, container ecosystem, where you can reuse a lot of these artifacts, which saves you a lot of time. Olly and I joke that if your favorite tool isn't up here, it's because they didn't pay us. So if they want to give us $5 at the end, we'll have a basket around. Cool. One of the great things that Docker can help you do is parallel testing. Certainly Docker isn't the only thing that can enable parallel testing, but it certainly helps because those containers are super fast. So the idea with parallel testing is that I can split up my testing jobs and run them in parallel, get them done quicker, get that feedback quicker, and then also reduce the amount of resources I have to use for my pipeline. So if you think of your container as just one process, then you can have many processes in these containers executing your tests. This can improve performance. You can just scale up by adding more containers. And then you're able to manage these container environments pretty easily with Docker ecosystem tools. In practice, this theory, it might be a little complex, but it's actually included in a lot of popular CI/CD tools out of the box, so you don't actually have to worry about writing it yourself. In addition to just speeding up execution of your tests, there are some other really interesting use cases, especially as Olly and I are going through some examples of Linux and Windows, and oftentimes together. So you might use parallel testing or parallel execution to cross-compile in Linux and Windows. You might use it to test against a matrix of versions. If maybe you're putting out an open source library, you want to make sure that it's compatible with a number of different versions. You can also run integration tests across different browsers at the same time. So you get a little bit more coverage and a bit better insight into browser compatibility of your web app without actually taking up more time. It's really easy to do this with containers. My one word of warning is that, and I have seen this, unfortunately, in production pipelines too often, parallelism is really great for running tests. But make sure you don't make the mistake of putting your deploy step in that parallel declarative block. That means your deployment is just going to run in parallel to all your tests, and your tests won't serve as that gate. I've seen this. It seems like sort of a silly mistake to make, but I've seen it all too frequently. So if you're brand new, setting up a pipeline, pay special attention to that. Make sure you don't fall into that same trap. Cool. I want to leave you with 2 examples before we get back to our Windows image, which should be finished building by now. This is an example of using Jenkins to cross-compile Linux and Windows. This is using parallel testing with containers, but also introducing yet another kind of cool feature, which is sequential stages. So basically, you're able to configure exactly what you want to run in exactly which order using a declarative pipeline in Jenkins. So over on the right-hand side, we have this very beautiful pipeline. And we can see we have, under this parallel heading, the stage Windows and then stage Linux, which are changing up if it's running on Linux or Windows and running build and deploy stages sequentially in each of those. Another example for those of you that are working on web applications, this is actually a really, really cool example that even Olly didn't know about until we put it in our talk. Selenium has this cool thing called Selenium Hub, where basically you have this, or Selenium Grid, you have a hub in the center, and then it sort of fans out, and you can have all of these different nodes testing different browsers and different operating systems. And up until recently, it was sort of Mac OS, Ubuntu, and now Windows finally is supported. So for example, you can test that your website or whatever looks great on Safari on iOS, but then also Chrome on Windows at the same time using containers. So speaking of Windows, why don't we hop back to DTR and see what's ready?
Cool. OK. So hopefully now, just a quick refresh, the build job would have finished. We would have successfully checked out our code from source control, ran a Docker build, built our container image, passed in our passwords, and pushed it all the way up to DTR. So a build agent came up, did what it needed to do, built my image, pushed the image off to my private registry, and then it would have disappeared. The build agent's done its job. It can now clean itself up and move away. Quick check in the private registry. Let me give it a quick refresh. Oh, log me out. Good. And the demo app. There we go. A couple of minutes ago, we would have seen the latest image get pushed with its git commit as its tag into our development repository. Now, one interesting thing you can see inside of our private registry here is we have vulnerabilities. So we have a nice kind of shoehorn into securing container images as part of your pipeline. OK, so kind of the security question that often gets asked, I've downloaded all these containers. I've just built all of these containers as part of my pipeline. The developer teams own the Docker files. I have no real idea what's inside of them. What happens if there's like out-of-date packages in there? What happens if there's like another OpenSSL vulnerability? How do I know what's running inside of my container image? And the response can't be, well, they came from the Docker Hub. They had an official blue tick next to them. They've got to be good. Or I've had a look at the Docker file, and it doesn't say there's anything bad in there. Like sad panda, that can't be the security response to container image hardening. And this has kind of come about because if you think of the old world, the developer only really cared about his application and his artifact. And the operators had to deal with the operating system and that middle layer. They built the jar. They didn't really care what version of Java it was running on type thing, whether it was patched, whether it was vulnerable. Whereas in the new world, in the container world, that middle layer has now been brought up inside of the container image. It's there. It's defined inside of the Docker file. So the question now becomes, who gives this area TLC? when you start to build those container images in your pipeline, who's making sure everything here is secure and is good to go. Now, I want to have a look at the Docker files, because that's often a good way for people to say, well, let's check in there. That should be the source of truth. Here, I've just gone onto the Docker store or Docker Hub, and I've downloaded the Oracle WebLogic image. Nothing particular about it. There's nothing special there. And if you can have a look here, we can't see anything really from the WebLogic layer what's inside. Moving one to the right, just following the base image down, well, let's see if the server JRE image told us what version of OpenSSL was installed. No, not there. Go one level further into the actual base image, the Oracle Linux base image, and it looks like they just copied a tarball into Scratch. Like, this is how most container images are built in the Docker Hub. This is correct. This is great. But me as an enterprise, I have no idea what version of OpenSSL are now running out there in the wild. Once again, sad panda. So image vulnerability scanning, as you just saw inside of our private registry, is a great way for us to get an insight into your container image. This is a report from one of my images. This actually isn't a report from the Oracle image. But it starts to show inside of your container images what are the components, and then compare those components with CV databases. So now you can start to see as part of your pipeline what's inside. And you can start to automate all of this through your pipeline. So for example, you just saw me build a container image. It had no vulnerabilities. My pipeline could end there. If it had clean and it had no vulnerabilities, I can automatically move it through to a testing phase, start off testing jobs, and have a webhooks at every level. I can start to build out a full end-to-end pipeline using the security checks inside. Docker also brings with another security check, and this enables you to control what actually runs inside of your cluster, and it also enables you to control what people use as their base images. This is something called Docker Content Trust. It's built on top of Notary and the TUF framework. But when you start to enable this on your clusters, and people start to run things like kubectl apply or just a Docker run, and Docker Content Trust is enabled, or you're trying to build and the from layer has not been signed, you will see things like did not meet required signing policy. So you can use this alongside security scanning to ensure everything that's going on inside of your pipeline, one, is clean of vulnerabilities, and two, meets the operational standards, uses signed base images, and produces signed data. Cool.
Awesome. So now we have a secure image to work with, and our next area of concern is actually deploying it into production. And we won't go very, very much in depth to the deployment part. There's some cool workshops to check out this afternoon if you want some more in-depth and detail about specifically how you can deploy to production. But the deployment is sort of the end of our software supply chain. So we've talked a lot about building the image, testing it, and then pushing it up to a registry. That's sort of the CI, continuous integration process. As soon as that image is pushed up and marked as eligible for promotion, that's where your CD, or continuous deployment, continuous delivery, kicks in. So you might have a Jenkins pipeline, create a new deployment, and then deploy that to whatever your production environment is. So in this case, let's imagine that we're deploying to Docker EE, running Swarm or Kubernetes or whatever orchestrator you want. The cool thing about orchestration services such as Swarm and Kubernetes is that a lot of these features for deployments are built into the tool itself, which means you don't have to write it in your deployment pipeline. For example, the deployment strategy of a rolling update is a feature of both Kubernetes and Swarm that you get out of the box without having to configure it in your pipeline. So let's take the example of a rolling update. This means I have a version of my software already running in production, and I have a new version that I want to introduce slowly, one by one, across all of the replicas of my service. I want to do this so that my application has no downtime. I don't want to just take off the old version and then spin up a new one. I want to do it gradually. It looks a bit like this, where I have the old version is purple, and then slowly introduce my new version here in yellow so that I can do a no downtime deployment. In Swarm and in Kubernetes, again, this is done for you. And there's a couple different levers that you can, and knobs you can turn to make it specifically fit your use case. So in your Docker stack file, if you're using Docker, you have this deploy key. And under there, we have things like replicas, but also this very important thing called update config. And we can see a delay, we've set parallelism, We've also set a max failure ratio to understand when to roll back. And we're going to roll back automatically because we've declared that failure action right there in our stack file. So that's written in code, committed to your source code repository. You can kind of set it and then use it without having to monkey with it too much. In Kubernetes, the rolling update is actually the default thing, so you don't have to explicitly declare it, but you can certainly. And there's also some little levers and knobs that you can twiddle with. For example, max surge, which means how many more containers can I have up as part of my rolling update. And again, that max unavailable. There's a couple other ones that you can check out in the spec. Again, there's no need to custom build this stuff because it's there for you in your orchestration system, but you need to make sure that your pipeline can monitor this and you actually understand what it is and what techniques you're using when you deploy something to production.
Cool. Now, we've got 5 minutes left. Let's go to kind of end-to-end demonstration now. So before I just built a container image inside of a build agent, I now want to go full end-to-end. I want to say, OK, push the image to the registry. If it's clean, start doing some testing jobs on it. If testing passes, a manual sign-off pushes it into a production repository. And then we can start to deploy, as Laura just talked about. So once again, I'm going to jump back to my environment. I'm going to do this one slightly differently, though. I'm going to do this one on Linux, and I'm going to do this one on Kubernetes. Once again, though, the same players are here. So we have Jenkins driving my pipeline. I have the registry for my image store, and I have Docker Enterprise for our Kubernetes environment. I have a new demonstration app, very, very similar. And if I jump to the demonstration app, I should be able to start off the pipeline in exactly the same way. In this environment, though, I'm actually just going to change the Docker file to go from an old base to a new base to switch to the new version of Alpine. And that should take care of some of the vulnerabilities inside of this container image and move it forward along the chain. So just commit that. And once again, sorry, Laura, I'm pushing up the master.
It's fine. I won't tell your boss.
Cool. Actually, don't know if I made a change. Yeah, that's already up to date. 1 sec. Let's go again. Sorry, I didn't make a change to start the pipeline. It was already clean. Cool. So now new change goes in source control. Pipeline's been started. Container build agents are time to be provisioned. So quick refresh. Excellent. We have a new change in source control. Jump back to Jenkins. Hopefully now it should get a notification and start to deploy ourselves a build agent. Cool. So build agent started. We've got something new in our queue. And hopefully then we should start to see new containers get deployed on our cluster. This is, of course, using Kubernetes. Rather than a standalone Docker run, I'm actually doing a kubectl. So you now see that I have a pod. So quick jump back to Docker Enterprise. Under pods, we should now see a new slave was started about a minute ago. Quick jump into the pod, 2 containers. One of them is my build agent. And once again, inside of here, I'm mounting the Docker socket. I'm using that approach to build containers inside of containers. So that will now go through. That will run. That's probably a bit quicker than the Windows image. We should expect that to be finished pretty quickly. There we go. It's done. Quick refresh of the registry. We should now see new tag landed 12 seconds ago, and it's clean. It had no vulnerabilities. This is where we scanned that image for vulnerabilities. We made sure that there were no out-of-date components in there. And we wrote some automation. If it was clean, promote this image from the developer repository, which was Dave's, to the testing repository along the way. Once you've done that promotion, fire off a webhook, tell Jenkins, new image is there, start to run your testing. Now, I'm not much of a developer, so my smoke test is pretty start the container, does it work? But we should now have a testing job. Quick look inside of my testing job. Once again, we would have had a new dynamically provisioned build agent. It's starting to go through its processes. One of the things you would have noticed here is that I'm actually going to do a kubectl apply. I'm going to deploy that newly built container on my environment. A quick smoke test, in this case, is a curl. Can I curl the web server? Did I break the web server in my change? I didn't. It's bounced back. Everything's OK. It's now going to do a quick cleanup. I've passed my smoke test. My pipelines, as you say, is built for demonstrations. I do actually have a manual check in here as well to say before I finish development, before I finish testing and move this image all the way to production, can I get some sign-off? Now, I assume in most places that's probably a pretty manual task. In my case, I just have a yes or no. We'll proceed, and that should now start moving my image all the way along, from build to test, and now going into production. Then that final step of production, I talked a bit before about Docker Content Trust and Notary. We're actually going to sign that container image. We're going to say that container image has been good to go. It's gone end to end through the pipeline, and it's ready to run in my production environments. Quick jump to the production repository. And give it a second. Last was an hour ago. OK, just pushing up there now. Already exists. Good. So there you've seen I've gone end to end from development, building my container in a container, moving to testing, spinning up more containers to test that my application works, and then finally moving it through to production where I have a clean image that has been signed off. The final step of my pipeline actually goes on to deploy that, and so you should see that new image start to roll out. Cool. Go back to the slides. Cool. All right. So thank you.
Great. Thank you all.